Hi, in this video, we're going to continue to talk about instance methods. This time, what's called the dunder string method. We said now it's very easy to create multiple instances of a car, which is true. However, to print out information about those two cars, I don't know how you would do it, but what I did was I actually wrote the first line and then I copy and paste. And I did not even change this properly. Did I change it here? Probably. Oh, yeah, look at that. I didn't fix it. It should be car 2, right? I copy and paste a line of code and change car 1 to car 2. Now, we don't like duplicating code, right? I said that many times already. So how can we make this a little simpler, that we don't have to, in order to get a human readable information about a particular object, right? We don't have to always copy and paste this code. Well, one thing we could do, since we have learned function, is that we can write a function that does this formatting, string formatting for us. So what I meant by that is this. So I can define a car info method. I actually probably have that piece of code. Or there. All right, I'm going to take this up here. And I'm going to paste it here. So I can define a function, right? Let's say car info, right? Given a car, I'll return a string. Okay, all that string is doing is that it puts the car's make, model, and year into a string and it returns that string. And then when I want to print things about car 1 and 2, I just pass the instance of car to this function so that it returns a string with information about the attributes of that car. And I just print that out. So let's see if this will work. And this should work. And of course, I should take this out. So the code now is, at least we're not replicating a whole lot of code. And there, I can print out information about the two cars. Okay, so that works. It kind of solves our problem of not duplicating code. But since we are studying our object-oriented programming, there is a object-oriented way of doing this instead of using functions. The idea is similar though. The fact that we want to form a string that describes an object is actually something that the object itself should be able to do, right? This is kind of like, when we go in for an interview, we're asked to, give a little description about ourselves. So we can, quote unquote, ask the object to describe itself for us. And it turns out that it's such a useful and important and common action that happens a lot, that there is actually another special method that is designed especially for this. And it is called the dunder string method. And how it works. So let me type that out. So I am going to define this as part of the car class string. Okay, and what it is, it's going to return, just like the function, it's going to return the make, the model, and the year. Now all of these car is kind of red because, okay, where is the instance? What instance are we trying to describe? Well, look at what kind of parameter we have for this dunder string method. It's self, just like the self in init. So that self is actually the the instance of the class that we want to describe. So rather than saying, you know, car, which we don't have here, we just say self. And that's the instance we want to describe. So I can get rid of this now. We don't need it anymore. And instead of calling car.info, we are going to invoke the string method on the instance of car. Okay, and we can do the same thing with car2 string. Okay, and let's run this. And there, it works pretty much the same way as before, but now the description of car is part of car, right? That's why we call this the object-oriented approach. Okay, now so a few things just about this string method that I kind of already showed, but let me emphasize. The first thing is, yes, the self, the parameter, is the instance of the car that we want to describe. And this method, now string method, it is expected to always return a user-readable, or human-readable string. Okay, it must return a string, and this string should describe the instance, and it usually includes all the attributes, right, at the minimum, and it could include whatever any information that you want to include. Okay, this is how you can invoke it. Okay, as we saw, the way to invoke it is just we start with the instance, do a dot, and then the name of the method. And finally, I know I've said this already, but it's important to see that the first parameter is self, and it is always it is the instance through which the method is invoked. So, right, because we invoke a string through this instance, self is really referred to this instance. So that's why, again, in the invocation, we don't really have anything inside the parentheses, because self is automatically assigned an instance, or the instance, right? Another way to see it is basically this instance is automatically assigned to the parameter self. And we're going to see this a lot in, well, we're going to see this in all the instance methods that we're going to define. Now, why does this have to be a dunder method? I mean, why can't we just simply call it, I don't know, something else, right? It doesn't, well, why is it a dunder? What's automatic about this? Well, it turns out most of the time you don't explicitly invoke dunder string. You can do this. And this is exactly the same as invoking dunder string explicitly by dereferencing car1 and car2. So if we run this, nothing should change here, because this is equivalent to what we just did before. Okay, and that's why this is a dunder method, because it's automatically invoked when you're trying to construct a string from a car object. Okay, and I think this would look familiar because we have done this before, right? And well, actually, before I talk about that, the reason that Python actually do this is one of the reasons, at least, is a string car. It's more readable than car.dunder string. Right? That's kind of, you know, what's going on here. But this is pretty familiar to us because we have done that before. When we want to convert say an integer to a string, we just put that integer into str to convert an integer to a string, right? So now we actually understand what happens in this case. In this case, what really happens is the in class has a dunder string method, and that dunder string method is it's implemented such that it will return a string for the number 10. Okay, so that's actually readable. Now, if you actually want to explicitly invoke int's dunder string method, you can write something like that. And I hope you agree with me that this is less readable than just that. Okay, that's why this is actually the preferred way to invoke the dunder string method to retrieve a human readable string about the object. Your turn again. So for the point class that you just wrote, define its dunder string method. So it should return a string that includes both the instance attribute x and y. And then now you can print out the instances by either invoking the dunder string directly or use the string method like what we did before. And you can even try that without converting your point to a string in a print statement and see if that works. All right, so go ahead and give this a try. Okay, so this is important enough that I actually typed that up. I just want to make sure that you actually get this correct. So fairly simple for the point. The initializer takes x and y, and it's going to remember those two values in its instance attributes, and the dunder string method should just say, x equal to whatever the attribute, and then y equal to whatever the attribute y is. You can create a bunch of points, and then here I show 3 different ways of calling the string dunder string method. First one explicit, like what we did. Second one using the string constructor, and the third one without any explicit call or conversion here. So does that work? Well, it works in all 3 cases. And then it's the last one that might be a new to some of you. And what happens here is that print is actually one of those methods that, because, well, when we print something, we always want to print a string of some sort, right? So print will automatically do the conversion to string for us, which in turn automatically invoke dunder string. So that's how this works. It doesn't work in all places. It depends on the particular function. Okay? So that's how it works. So just another kind of a word about these dunder method. We've now seen 2 of them, dunder init and dunder string. And they are just, I show them right now because they're the most common ones, and there are actually many others that we might study later, either in this class or in a later different course like 3B. We can We can call these dunder methods explicitly, especially the dunder string, right? But more often than not, we don't call them explicitly because Python just knows when to invoke them at the appropriate times for us. So as you already saw, the dunder init is called when an instance is created and it needs to be initialized. And then dunder string is called when we want to convert a string, convert an arbitrary object into a string. Okay, so dunder init, you probably never explicitly call it. Dunder string, maybe sometimes. But most of the time, you should do this because that's more readable. Some words about a self parameter. Okay, I know I said this many times, but it's very important. That's why I think it's worth repeating, is that all instance method, the first parameter always refers to the instance through which the method is invoked. Okay, so again, in this case, this is the instance we invoked dunder string, and that instance is assigned to the first parameter of dunder string. Now, here's the interesting thing. It doesn't have to be called self. You can really call it anything, right? Anything that is a valid identifier, obviously. There are only so many valid identifiers. I think you cannot start it with a number. You cannot put a space in the middle, obviously, and things like that. But as long as it's a valid identifier or a valid name, it can be anything. By convention, it is self, and I don't think I ever seen it being called anything else. Okay. One thing is that the instance attributes are created on an instance or on an object, right? By dereferencing self, right? We saw how to do this in the initializer. So the instance attributes, they live as long as the instance itself, right? That should not be any surprise. So once you create an instance and then create an attribute for that instance, the attribute is going to stay with the instance until either you explicitly delete the attribute, which you probably don't do very often, or somehow the the instance is gone. But we don't explicitly delete instance in Python anyway. So anyway, the important thing to realize is if you don't use the self dot, but give it a name, a local variable is created for the function, and it only lives inside the method. So for example, here you should probably try this in your IDE. Create a class called foo and define a method called bar, and you create a local variable without self dot in front of it. Okay, so what you created here is a local variable inside bar. Okay, so well, actually I kind of missed something here. So even if you call bar and that local variable is created inside bar, once you're done with bar, that local variable is gone. So you can no longer refer to the local variable no matter what you do. And you definitely cannot find that local variable as an attribute of the instance of foo. Okay? So keep that difference in mind. I know, well, I've seen many students when they first started object-oriented programming, they forget to put self dot in front of an attribute they want to create for an instance and wonder where it's gone. So put self dot always in front of an instance attribute. One more slide, I believe, about self and the instance attributes. And I kind of want to put that into a perspective, particularly for those of you who know C++ and or Java. So the self in Python is in many ways similar to this in the C++ or Java. And all of these languages have instance attributes. There are some differences. Okay, the first one we already saw. Self in Python doesn't have to be named self, but this in C++ and Java must be this. Okay, because it's a keyword. It's very special to those languages. Secondly, I know I probably sound like a broken record by now, but self is explicitly the first parameter of all instance methods. But this in C++ Java is not. There's no explicit first parameter of any instance methods, right? And then finally, is something that I just kind of said, is the instance attributes in Python that always explicitly they are accessed by always explicitly dereferencing an instance. That instance can be self or can be whatever name you assign an instance to, right? It can be a variable. Okay, so that's good because that's very consistent. You never access an attribute without an instance. In C++ or Java, it's not always that way. So sometimes, even if you just reference a name, it could be a local variable or an instance attribute. So in that way, Python is actually, in my opinion, better designed.